Hello everyone. In this video, we are going to discuss the multiple choice type questions related to fiber optics. Question number 1 में पूछा गया है कि in an optical fiber, the core material has refractive index of 1.43 and refractive index of clad material is 1.4. Then find the critical angle at core cladding interface. So given that N1, that is refractive index of core, is 1.43 and N2, that is refractive index of cladding, is 1.4, and we know that at core cladding interface the critical angle theta c is defined as cos theta c is equal to n2 by n1. If you substitute n2, that is 1.4, and n1, that is 1.43, you will get 0.979. Okay, so if you further solve it, you will get theta c is equal to 11.8 degree. So the correct option is option number A. In question number 2, again value of critical angle is asked, and it is given that the core material has refractive index N1 is equal to 1.6 and refractive index of clad material is 1.3. So as we have just used the formula cos theta c is equal to n2 by n1, and if you will substitute here 1.3 divided by 1.6, and if you further solve it, you will get 0.8125. So it will give you the theta c value as 54.3 degree. So the correct option is option number B. In question number 3, it is asked that calculate the numerical aperture of an optical fiber from the following data. Refractive index of core is given, that is mu1 is equal to 1.55. Refractive index of cladding is also given, and it is mu2 is equal to 1.50. Now we have to calculate numerical aperture. We know that numerical aperture is defined at square root of mu1 ka square minus mu2 ka square. Now let's substitute the values 1.55 ka whole square minus 1.50 ka whole square. If you further simplify it, you will get 0.391. So the correct option is option number D. In question number 4, again we have to calculate the numerical aperture of an optical fiber cable in which refractive index of clad is 1.378 and refractive index of core is 1.546. So N1, that is the refractive index of core, is given 1.546, and N2, that is the refractive index of clad, is given 1.378. So numerical aperture again, which is defined as n1 का square minus n2 का square का square root, and if you substitute the values you will get 1.546 का whole square minus 1.378 का whole square. If you will simplify, you will get 0.70. So the correct option is option number C. Question number 5 is, if fiber cable has an acceptance angle of 30 degree and core index of refraction of 1.4, calculate the refractive index of the cladding. So it is given that acceptance angle theta 0 is equal to 30 degree, and refractive index of core is also given, which is 1.4. Now we have to calculate N2, that is the refractive index of cladding. So we have the relation sin theta 0 is equal to n1 square minus n2 square, and it is your numerical aperture. So sin theta 0 is, you can write it at sin 30 degree, and at n1 square minus n2 square you can write 1.4 का whole square minus n2 का square. Squaring on both sides, you will get 1.4 and 1.4 का whole square minus n2 का square. Okay, so it will further give you n2 का square is equal to 1.96 minus 0.25. If you solve it, you will get n2 is equal to 1.308. So the correct answer is option number A. In question number 6, it is asked to calculate the fractional index change for a given optical fiber if the refractive index of the core and cladding are 1.563 and 1.498. So it is given that refractive index of core is N1 is equal to 1.563 and refractive index of cladding is 1.498, and we have to calculate fractional refractive index, which is defined as delta is equal to N1 minus N2 divided by N1. So N1 is 1.563, N2 is 1.498, and N1 is again 1.563. So if you will simplify it, you will get 0.065 divided by 1.563, which will give you 0.0415. So the correct answer is 0.0415. So the option number C is correct. Next question is fractional index change for an optical fiber is 0.0067. Find the numerical aperture if refractive index of core is 1.5. So in this question, fractional refractive index, that is delta, is given, that is 0.0067, and refractive index of core is also given. Okay, now we have to calculate numerical aperture. Okay, so numerical aperture is related to fractional refractive index by the expression n is equal to n1 to delta. Okay, so substituting n1 and delta values 2 into 0.0067. Okay, when we will solve it, we'll get 0.174. So the option number A is correct. Question number 8 is, what is attenuation in decibel per kilometer if 85% of the power fed at launching in of a 1.2 kilometer fiber is lost during propagation? So here we have to calculate the attenuation, and we know that expression for attenuation in decibel per kilometer is 10 by L log Pi by P0, where Pi is the input power and Pu is the output power. So given that L is equal to 0.5 kilometer, okay, this is the length of optical fiber, and it is said that 85% our fed at launching it is lost during propagation. So output is only 0.15 of input. Okay, now substitute p0, sorry, pi by p0, that is 1 upon 0.15 in this equation. Okay, so we'll get alpha is equal to 10 by L log 1 upon 0.15. In place of L, we can write 0.5. If you solve it further, you will get 16.48 decibel per kilometer. So the correct answer is B. Again, in question number 9, we have to calculate the fiber attenuation. It is given that optical power of 1 milliwatt is launched into an optical fiber of length 100 meter. If the power emerging from the other end is 0.3 milliwatt, calculate the fiber attenuation. Four options are given. 52.3 decibel per kilometer, 16.48 decibel per kilometer, 8.24 decibel per kilometer, none of these. So, given that Pi, that is the input power, is 1 milliwatt, whereas output power is zero point 0.3 milliwatt, and length of the optical fiber is only 100 meter. Okay, so what is fiber attenuation? Optical fiber attenuation is defined as 10 by L into log Pi by P0. So L is length of the optical fiber. It is 100 meter. So you can write it in kilometer as 0.100. Okay. Log Pi is 1 milliwatt and Po is zero point 0.3 milliwatt. Okay. So if we'll further solve it, we'll get 52.3 decibel per kilometer. Okay, so the correct answer is option number A, that is 52.3 decibel per kilometer. Question number 10 is, a step index fiber is made with a core of refractive index 1.52, a diameter of 29 micrometer, and a fractional difference index of 0.0007. It is operated at a wavelength of 1.3 micrometer. Then the number of modes that a fiber will support is. Four options are given: 32, 16, 8, and 12. So we have to calculate the number of modes that a fiber will support. We know that number of modes that a step index fiber will support is given by Nm is equal to V square by 2, where V is the normalized frequency and is also known as V number, and it is defined as V is equal to pi d by lambda 0 into N1 square root of 2 delta. Okay, here D is the diameter of the core, N1 is the refractive index of the core, and delta is the fractional refractive index change, and lambda 0 is the operating wavelength. So in this question, it is given that D is equal to 29 micrometer, and delta is also given, it is 0.0007. N1 is also given, it is 1.52. Lambda 0 is also given, it is 1.3 micrometer. So if we substitute these values in the expression for V number, we will get 4.069. Okay, therefore the number of modes we will be allowed will be given by will be approximately equal to 8. Okay, so the correct option is C. Next question is, a step index fiber is with a core of refractive index 1.55 and cladding of refractive index 1.51. Compute the intermodal dispersion per kilometer of length of the optical fiber. So in this question, we have to calculate intermodal dispersion for 1 kilometer. Okay, so the relation for expression for intermodal dispersion is delta T is equal to N1 L by C in bracket N1 by N2 minus 1. Here N1 is refractive index of core. Okay, N2 is the refractive index of cladding, and L is the length up to which dispersion is calculated, and delta T is intermodal dispersion. So in this problem, it is given that N1 is equal to 1.55, N2 is equal to 1.51, and L is equal to 1 kilometer, that is 1000 meter. Okay, so if we substitute these values in this expression, we will get delta T is equal to 1.55 into 1000 divided by C is the light velocity, so it is 3 into 10 to power 8 meter per second is also meter, and N1 is 1.55, N2 is 1.51 minus 1. If you will solve it, we'll get 138 nanosecond per kilometer. So the correct answer is A. Option number A is the correct answer. In question number 12, it is asked that calculate the angle of acceptance of a given optical fiber if the refractive index of core and cladding are 1.563 and 1.498 respectively. Four options are given. First option is 13 degrees, second option is 35.5 degree, third option is 26.49 degree, and fourth option is 53.1 degree. Now let's see what is given. So it is given that N1, that is refractive index of the core, is 1.563 and N2, refractive index of cladding, is 1.498. Now we have to calculate the acceptance angle, that is theta 0. So we know that relation between acceptance angle and refractive index of core and cladding is sin theta 0 is equal to square root of n1 square minus n2 square. So now substitute the values and we will get 1.563 ka square minus 1.4983 ka whole square. Okay, when you will solve it further, you will get 0.4461. Okay, so this will give you theta 0 is equal to sine inverse 0.4461. After further solving it, we will get 26.49. So the correct answer is option number C. Thank you for watching and listening the video.